This lesson is part 1 of sections 6.3 and 6.4. We're going to be working with exponents. So today I'm going to review all of the exponent properties that you should be sort of familiar with already. I know it's probably been a while since you've taken Algebra 1, but we're going to simplify a bunch of expressions using all of the exponent properties. So let's start with the product of powers property. X to the a times x to the b is equal to x to the a plus b. When you see powers and you are multiplying them, okay, so in other words, if I saw x squared plus x to the third, this rule does not apply because we are not multiplying something with the same base. So in this case, if I had x squared times x cubed, then I would apply this rule. And what I'm going to do is keep the base, and I simply add the exponents. So in this case, x squared times x to the third is x to the fifth. So quickly, I'm going to go through these. You can pause here and you can try these on your own and then check with the key. That's actually what I would recommend because in my opinion, the hard part is recognizing when you have the same base and what to do with your exponents from there. So number 1 is going to be x to the 12th because I'm simply adding 4 and 8. Now in number 2, I actually have negative 2 to the 7th power. So we talked about this a little bit already. When you have an odd number, a negative number raised to an odd power, overall, your answer should be negative. So we need to make sure that we understand that when I repeat this 6 times here, I might have a positive 2 to the 6th, but when I multiply by another negative 2 here, overall my answer should be negative. I like to write that out right away and put that negative there just before I even start to evaluate the rest of that. Now 2 to the 7th is something that you should be able to do pretty easily. Think of 2 squared, 2 to the 3rd, 2 to the 4th, 2 to the 5th. If you don't have this memorized, that's okay. You can start with something you do know. Let's say you knew that 2 squared was 4. From here, you're just going to continue to raise it to another power. So you're going to multiply each of those by 2. And so this might not be something, again, that you have memorized, but you can certainly get to that. So we get 2 to the 7th is 128, so I have negative 128 there. Now on number 3, I have a 3 to the first power here. Now, a multiplication doesn't really matter the order here, so I can actually rewrite this as 3 times 3 times 3 times z times z times z, which means I now have 3 to the third power, because remember each of these is to the first power, and I'm simply going to add the exponents, and then z to the third power as well, because each of these is to the first as well. And if I evaluate that, I'm left with 27z cubed. Number 4, here I actually have a different base for the numbers, so make sure that you see this is just a normal multiplication problem. This is simply 3 times negative 2, which gives me negative 6, and x to the 6th times x gives me x to the 7th, and I have this other y here to the first power. I'm just going to rewrite that y. It doesn't have any other exponents, so I just keep it as y. Alright, the next rule, power of a power property. Now here when you see a set of parentheses, and outside of the parentheses is an exponent, all you have to do is remember to multiply. Basically, you're distributing that this exponent out here. So we take the product of a times b. So you keep the base and you multiply your exponents. So for example, in number 5, this is simply y to the 12th power. Now, let's say you forgot all of these rules that I'm going to go over. You could always expand this and use your first basic rule that we went over. Whoops, that's a 3. Y to the third to the 4th power is simply y cubed times y cubed times y cubed times y cubed, which after that you can just add your exponents together and you're going to see that you get the same thing. Okay? So in number 6, I have negative 6 squared to the 5th power. You can do this 2 ways. You could say that this is negative 6 to the 10th power, or you could say that this is 36 to the 5th power. Now why am I able to say either of these things? Well, I have a power raised to another power, so I can just multiply those, keep the base, so I have negative 6 to the 10th, or I could choose to evaluate the inside here, so I just rewrite negative 6 squared as a positive 36, and then raise it to the 5th power. Now in both cases here, this is going to be a huge number, so we're not going to make you write this out or evaluate that unless you did have a calculator with you, but in this case I'm just going to leave that answer as it is. Now in number 7, I'm simply going to multiply those exponents to get x to the 15th. And in number 8, I have negative 4 raised to the 15th power. So overall, I would simplify this answer because I know that this product here should be negative. So when I finally find that answer, it definitely will be negative, so I'm going to stick the negative outside in front. So it's negative 4 to the 15th power. And again, this is really huge, so we'll just have you stop right there. All right, next property, the power of a product property. Now this time I have two different bases on the inside raised to an exponent. So each of these is a separate base. That's why I'm raising each base to that power. So when raising a product to a power, you raise each base to the power. Okay? So for example, in number 9, x squared times y raised to the 4th power. After I basically distribute both of these, I get x to the 8th times y to the 4th. In number 10, I have 3 separate bases. Negative 3 is actually its own base. So make sure, one common mistake that I see is negative 3 times 4. Kids will write that as negative 12. That's clearly not the case though, because this is negative 3 raised to the 4th power, c cubed raised to the 4th power, which is going to be c to the 12th, and d squared raised to the 4th power becomes d to the 8th. So now if I evaluate this, and this is something that you will have memorized, negative 3 to the 4th power is positive, and it's a positive 81. So I have 81 c to the 12th, d to the 8th. In number 11, I'm raising each base as well. So this is 4 squared times a to the 6th, which gives me 16a to the 6th. Now number 12 can be kind of confusing for some students because here I have negative 3y raised to the 4th power. Now this negative sign here is not really part of either of those bases here. So really if I were to expand this, this is only negative 3, or the opposite of 3y times 3y times 3y times 3y. The 3y is being repeated 4 times, but the negative is not. So overall, I should have a negative value here. So I have negative 3 to the 4th times y to the 4th, which is negative 81 y to the 4th. So it's these very subtle differences that make it kind of confusing, I think, when you have to simplify on your own. So make sure you understand these rules. Next one, quotient of powers property. When you have powers with the same base, you are going to subtract the exponents, and you're going to simply keep your base. So here I have x to the a over x to the b, so this is a quotient because I'm dividing these two values here, and I simply subtract the exponents. So in problem 13 here, x to the 11th and y to the 7th, well, I cannot subtract these because these have different bases. So my final answer here is actually just x to the 11th over y to the 7th. Now in 14, this might look really tough for you to have to evaluate, especially without a calculator, but this actually simplifies and makes it pretty easy on you if you use this quotient of powers property. 6 to the 5th over 6 to the 3rd, I can simplify that as 6 squared. And 3 to the 3rd over 3 to the 2nd, I can simplify that and make that 3 to the 1st. I'm simply going to subtract my exponents. Then I'm left with 36 times 3, which is just 108. Oh wait, is that 118? 18, oh, it's 108. Okay, next up. 15. Here, I could do this problem a couple different ways. So if we looked at the first rule here, in our first rule, we know we're supposed to add the exponents here. So that gives me 12 to the 8th, and then I have the quotient, so then I'm going to subtract, and I'm left with 12 to the 6th. Now, you could do it a second way, and that's to say, okay, 12 to the 5th over 12 squared. Well, this has 3 more 12s, right? So 12 to the 3rd. And then since this is completely gone now, I have 12 to the 3rd times 12 to the 3rd left, which is also 12 to the 6th. What I will sometimes see people incorrectly doing is saying, oh, okay, well, I have to subtract here and I have to subtract here. But that's not really the case, because the reason why you can subtract is because these 12s will actually end up canceling each other out. So if I were to expand the top row, 12 to the 5th is this part here, and 12 to the 3rd is another 3 12s. And in the bottom, I only really have those 2 12s, so if I show the work here to cancel them out, you can clearly see why I have 6 left over. And what I normally see as like an incorrect answer here is somebody will write, that goes in there 3 times, and then this one here is 1, so they write their answer as 12 to the 4th. So they overcount the denominator, the 12 squared, twice because they subtract this part too. So don't do that. Okay. Next up, number 16, we have 3 different bases, and we're just going to subtract the exponents, and we're left with a cubed, b to the 5th, and c. And this would be my final answer. I'm using the quotient of powers property. Next, when you take the power of a quotient, so notice you have an exponent raised outside of a quotient, you have to actually raise both bases here to that quotient, or to that power. So to raise a quotient to a power, you raise the numerator and you raise the denominator to the power. Okay, make sure that you're distributing that to both the numerator and the denominator. A lot of students forget to do that. So here I simplify this as w to the 6th over p raised to the 5th power. That's one way to do this, and just to simplify right away. So I'm left with w to the 30th over p to the 5th. I need to make sure that I take the numerator and the denominator and raise them both to the power. In number 18, I think this is a little bit more complex. It's a step up definitely from what we've been working on, because we're using a bunch of different rules here. Now, we're raising this to the 4th power. So we have a negative raised to an even power, which means that overall this should be positive. So I'm going to drop the negative completely, because I know that no longer will I see a negative in my final answer, because this is going to end up being positive 2 to the 4th, and c to the 12th, and b to the 4th. Now what you could do if you wanted to is raise that here and multiply these two exponents to get 8, and you could raise this to 8th power. But I really like, just as a rule of thumb, to always simplify first. So I like to simplify as much as I can before I start raising anything on the outside. So you will need to make sure that you rewrite this all squared, but I like to simplify as much as I can on the inside before I actually take an exponent on the outside. It just keeps the work a little bit neater for myself and makes sure that I know what I'm doing as I go through step by step. Alright, now in the denominator, I really can't simplify anything here because these are all different bases. But now when I look at my overall answer here, I have 2 to the 4th, which I will evaluate, so that's 16. And I have c to the 12th over c squared. So c to the 12th over c squared is simply c to the 10th. b to the 4th over b squared is b squared. And I still have that 3 in the denominator. Now 16 and 3 divided by 3 that's simply a fraction here, a quotient. 16 divided by 3. Don't write that as 13, which is what people a lot of times do, because they think, oh, I see this in the numerator and this in the denominator, I'm supposed to subtract. So they subtract here too, even though these are just normal numbers, 16 divided by 3. So they're not exponents, so make sure that you don't treat them like an exponent and subtract. Okay, so the last thing I have to do now is square everything. So I'm going to distribute this, since I have 1, 2, 3, 4 different bases. I'm going to distribute that to 4 different times. So I have 16 squared, c to the 20th, and b to the 4th, all over 3 squared. So 16 squared is also something I would like you to have memorized. So we get 256, c to the 20th, b to the 4th, over 9. And this is reduced already. You could check to see if it's reducible. You can maybe try to divide that by 9 or that by 3, but this is already reducible because I cannot reduce 16 thirds. Okay? All right, in number 19, I would simplify the denominator first and take that to the 3rd power. I'll let you guys work on that on your own, as well as number 20. Try to simplify before you raise everything to the 3rd power. Okay, so 0 exponents are a little special. Whenever you see an exponent that it happens to be a 0, you need to remember this fact, that anything raised to the 0 power is 1. So, for example, x to the 0, the numerator will be 1, y squared, and the denominator stays y squared. Now here, everything here is raised to the 0 power, so you could do this one of two ways. You could distribute here, and you end up with everything having to be to the 0 power because you're multiplying each of these. Or you can just simply see that you have a base, and although there are a lot of bases in here, there's 3, everything is raised to the 0 power, so overall this should be 1. In number 23, x to the 5th times y cubed over y to the 0, you could simplify the inside and say that this is x to the 5th times y cubed, because if we simplify here, we just subtract our exponents and we're left with y cubed. So you're going to raise that now to the 2nd power and get x to the 25th, or sorry, x to the 10th. So you just multiply those, don't square 5 squared, which is what I just did mentally. See, it's really easy to make a lot of errors in this, so try to avoid that. And I just did it again. So it's not 3 squared, it's 3 times 2. Sorry about that. Okay. Please try 24 on your own and check with the key. It's pretty basic, I think. And the last rule that we're going to go over is negative exponents. When you see a negative exponent, you're simply going to take the reciprocal of the fraction. So take the reciprocal. Basically, when you write out your final answers, you should never see a negative exponent. That means it's not simplified all the way. So in your final answer, no negative exponents and only one type of base. So we'll talk about that in a second. But I have this stupid rule, like little story, I guess. It's not really a story, but a little way to remember this. When you see this exponent, you're going to think of him as being unhappy. Right now he's upstairs because in a fraction he'd be on top, okay? And he's unhappy right now. So to get happy, he goes downstairs. I don't know, maybe he's mad at his parents and he just wants to get away from them. But that negative exponent becomes positive once he moves from the upstairs to the downstairs. Okay, so you drop the negative completely when it moves to the bottom. Okay, so when you take the reciprocal, the negative goes away. Now, if he's unhappy because he's in the basement and he wants to go upstairs, well, now a to the n is over 1, and you now no longer see that negative exponent here. All right, so let's start here with problem 25. You got to remember that not everything is unhappy also. Only this x is unhappy. X to the negative fifth is unhappy. So the y to the fourth will stay upstairs, while the x to the fifth will move to the downstairs. Okay, notice that it's no longer a negative. I also don't put a negative sign out in front. That's not what a negative exponent means. So please do not do that. So I'm left with y to the fourth over x to the fifth. One of the mistakes that I see, and I should have put this on number 26, if I put a negative here, a negative 16, everybody now, since we know this rule, wants to move the negative 16 to the bottom. But this is not an exponent, it's just a number, so even if it was negative, it would stay negative 16. So please don't overuse this rule either. So here I've got some simplifying that I could do. I always like to move negative exponents before I even begin simplifying anything else. So I see that I have a negative exponent here, here, and here. And so I'm going to move everything to begin with. I'm going to copy down all of the other work. And so I'm going to move that m to the negative 7th up to the top. And the only thing that's left up top is also going to be that m to the 1st. The z to the negative 2nd now wants to go down to the bottom. M to the negative 7th wants to also move to the bottom. And then I also have this z cubed here. Okay? So it sometimes does help too to go left to right. So the 16 stays, n squared stays. Z to the negative 2nd would move to the bottom. M to the negative 7th would move to the bottom. M to the 1st would stay. Then working on the denominator, m to the negative 7th would move to the top. Z cubed would stay. So you really want to approach these piece by piece and show work. A lot of people will try to do all this in their head. They make a lot of silly errors. I like to show work. You should show work. If I don't even like to not do, or not show work, you should at least show it too, because I've been doing this for a lot longer than you. So please show work. Okay, now I'm left with, after I simplify here, m to the 8th in the numerator. So I can write that as 16n squared times m to the 8th over z to the 5th now, because I have these I can combine, and then m to the 7th left. Now, you can't leave this as your final answer because, and I talked about it just a second ago, you have the same base here written twice. You should only see one base basically per variable. So you can have a 16 here. The n squared is fine, but I'm going to subtract the exponents here for the m to get just an m to the 1st, and that z to the 5th will stay in the denominator. Okay? So that's my final answer because I see no negative exponents and only one of each type of base. Now in 37, this negative 2 only applies to the y. The 3 will stay exactly where it is. The y to the negative 2nd will move. In number 28, this is 3y to the negative 2nd power, which can be written two different ways. 3 to the negative 2nd times y to the negative 2nd, or this is a trick that I like to use because it simplifies a lot of the process, especially if it's already a fraction. I should have done a problem like this. Here, you can flip and take the reciprocal right away and then take the positive exponent. You could do this as well, instead of distributing basically to both of these terms. Okay? So anyway, here, I can just take the reciprocal and make that exponent happy by moving them downstairs. So this, you'll see, it gives me the exact same answer whether I distribute that exponent or take the reciprocal first. So if I distribute the exponent, 3 to the negative second moves to the denominator, y to the negative second also moves to the denominator, so I now have 1 over 3 squared over y squared. You can't have just nothing in the numerator, so make sure you put at least a 1 there. So you have 1 over 9y squared. Here, I would get the exact same thing. If I just take the squared for each one of these, if I distribute that 2, I get 1 over 9y squared. Same answer. Alright, that was a lot of problems, and I kind of went through them quickly. Hopefully you checked with the key if you tried to go through any of this quicker. Good job. I'll see you in class mañana.